Well, good morning. Um, Welcome back from spring break. I am going to walk through some probability notes for you, and then you will work on today the Activity 4.1 Data Exploration Activity. I should have all that paperwork. The data for the Activity 4.1 is also in your Project Lead the Way online account. So anyway, we'll walk through some stuff, and we won't do all these notes today. We'll just get through the first part, and then we'll talk a little bit about using your calculator, and you're going to have to bear with me as I probably bumble through some screen recording, working on all this new stuff. So anyway, probability. So probability is the calculated likelihood that a given event will occur. We use probability probably more in our daily life than we actually even realize. We talk about probability with sports. We talk about probability with weather. All kinds of things. You'd have the games that you play. What is the probability you're going to roll a 6? Anyway, probability is used in the daily world, daily life, all the time. There are 3 types of methods to determine probability. We have empirical, and that's essentially an experimental observation. You actually do the rolling. You roll the dice. You draw a card from a deck, and you record your data, and then you, at the end, figure out what was your experimental probability. So you might roll a dice 10 times, and you want to know what you want to know what is the probability you're going to get a 3, and maybe you only got a 3 2 out of that 10 times. So you have a 2/10 or 1/5 of the time that was your probability of getting a 3. Think about process control. They will actually maybe take parts off of a line and look at them to see if they're defective or not. And then they might do 2 parts per 1,000, and or they might do a sampling and see that 2 parts out of the thousands samples that they took, they can determine what their probability of getting a defect on their process line. You have theoretical probability. That's where you actually take the known elements. So you know when you have a dice that you have a heads or a tails. So the probability is getting a heads is 1 out of 2. When you roll a dice, the probability of getting a 3 is 1 out of 6. So those are using the known desired outputs that you have. Then you have subjective probability. So that's based on taking information that you know from before and using it to make a prediction. So you might, weathermen, they use subjective probability all the time. What is the probability that's going to rain on Thursday? There's a 30% chance of rain. Well, they're taking all their data based on cloud patterns and whatever weathermen do here, and making a prediction. We're kind of doing some of that with, this whole coronavirus. They're using some probability, of whether or not you're infected. They're taking data and making some predictions with it. Okay. So again, in the real world, for engineers, in the engineering world, we use probability to, one of the ways they do it to make sure that what is the likelihood of a failure occurring. So they're going to take a lot of data to see what it's really about failure. You don't want to produce parts that are bad or have processes that are bad. So you do use a lot of probability data to determine that. Okay, so we have probability components. We have an experiment, the sample space, the event, and the outcome. So the experiment is the activity with observable results. This is where you actually, you're going to do it today. You're going to roll a dice. You're going to flip a coin. And that's actually doing, and you're going to get that data. When you have your sample space is the set of all possible outcomes. So a coin has 2 outcomes, heads or tails. A dice has 6 outcomes, 1, 2, 3, 4, 5, or 6. A deck of cards has 52 possible outcomes. Your event is the subset of your sample space. So your event is the actual thing that you're measuring. So if I'm flipping a coin and I want to know what is the probability of getting a heads, the event is the heads. How many times did I get a head? And then your outcome is the result. So what is the probability that you end up getting? when we talk about in the real, in an engineering example, you might test a brass sample to find its tensile strength. That would be the experiment. If it might break under any load from 0 to 1,000 pounds, or it might not break at all. Okay, so that would be your sample space. It's going to break or it's not going to break, depending on the weight that you're putting the pressure under. One possible outcome might be that it could break at 200 pounds. That would be your event. And then when you perform the test, it breaks at a particular load. That would be that's your outcome where it broke. So anyway, moving on. We're going to keep it really simple. We're going to do an experiment here where we want to know what is the probability of a toss coin landing heads up. Well, the experiment is tossing your coin. The sample space is it can be heads or tails. The event we're interested in is heads, and if we flip it and we get an outcome of heads, then that's your outcome. And then you would have a probability of, in this case, this just one toss is 1/2. Now, when we actually give those numbers out, that's the way of communicating that the belief that an event will occur. So that's what probability's definition is. This probability can be expressed as a number between 0 and 1. It is never negative, and it is never greater than 1. Now, if you do it as a percent, you can change that percent between 0 and 100%, but it will never be greater than 100%. Odds is a little different here. They threw that on the end. Odds has a little different formula, so I'm not sure why they want to put it in probability. It's related to probability, but we don't actually talk about odds, at least not that I can find. If you take another statistics class, you might do more with odds. If we take the probability of all the possible events, they have to add up to 1. So the probability of something occurring plus the probability of it not occurring has to add up to 1. The term used in probability is relative frequency. That is really just the number of times the event will occur divided by the number of opportunities. So it's often a little f, but in the end, this is also going to just be our probability, where the number of events that have the outcome that were desired is going to go in the numerator divided by the total number of events that goes in the denominator. Most of the time, this is expressed as a decimal, but they say they can be expressed as a fraction, percent, decimal. Again, they throw in this odds, but that's a little different than probability, straight up probability, but we'll talk about that. Or actually, I'm sorry, I said we won't talk about that. I don't think they have anything to do with odds here. Okay, same stuff as before. All right, so what is the probability if we take a coin and we toss it? What is the probability that it's landing heads up? Talked about this briefly. The desired event is 1. We're just interested in whether it's a heads. Then the total number of possible outcomes is 2. So the probability is the frequency of the desired events over the frequency of the possible outcomes. So we have a probability of 1/2. What is the probability that our coin will land tails up? Well, still, the desired outcome is tails, so that's just 1. And the possible outcomes, there's 2 still possible outcomes, so the probability that it will land tails up is still 50-50, or 50%. Now, what if we take 2 coins? Oh, I'm sorry, it's the same coin. Sorry. Same coin, and we want to know, we're going to roll it twice, though. What is the probability that it will land heads up both times? So, again, our desired event, desirable outcome is just, there's only 1. We want them both to be heads, so heads, heads. And then we want to know how many possible outcomes. So if we look at this, they drew a little decision tree for us. This is our first toss, heads or tails. And if I toss heads first, I can toss again and I can get heads or tails. If I toss tails first, I can then toss it again and I could get heads or tails. So on this right-hand side here is all our possible outcomes. I could have had a heads, 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 tails, tails, heads, or tails, tails. Heads, heads is what I'm interested in. So there was 1 heads, heads, and there are 1, 2, 3, 4 possible outcomes. So I have a 25% chance, or a 0.25 probability of getting heads if I toss a coin twice. Now we have a big decision tree for the possibility of tossing a coin 3 times and having it land on heads exactly 2 times. So the first toss is heads or tails, and then if you go up here to this top one, my second toss can be heads or tails. If I go for the very top one here, my third toss could be heads or tails. So this one is heads, tails. I'm sorry, heads, tails, and then we could keep going down. I don't want to walk you through all of that. But if you look at the right-hand side here, these are all our possible outcomes, all the different combinations that you could have with your tosses. And so we have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes, but only 3 in this kind of brownish color have 2 heads in them. So we have 3 out of 8. So we have a 37.5% chance of, or probability of, getting 2 heads if we toss a coin 3 times. Okay. We also have this process called the binomial process. Each trial only has 2 possible outcomes. So, heads, tails, yes, no, on, off, right or wrong. Even a dice can be a binomial process. You could say, what is the probability that I'm going to get a 1? And then the other options would be not 1. So it can have multiple, you can kind of group sometimes outcomes into one outcome. Multiple choice question could be, what is the probability that my answers is going to be a B? Okay, so that would be your one outcome, and your other outcome would be not a B. So true, false would be another binomial process. So binomial meaning two outcomes. Think of a bicycle, 2 wheels. The 2 outcomes also have to be independent of each other. So the tossing of coin does not affect the future tosses. So same thing with rolling a dice. You roll a dice once, whatever you rolled the first time should not affect the roll for the second time. Okay, there's this crazy formula for a binomial, or this binomial process, and it's called the Bernoulli process. And it has a lot of different, I'll walk through it, and then I'm going to show you how to do this on your calculator, so we don't need to worry about memorizing a formula. This P is the probability. This is for, like, I'm going to back up a step here. This is for, like, I want to know what is the probability that if I roll a dice, let's do a flip a coin. That's an easy one. I flip a coin 10 times. What is the probability that it is going to be heads 6 of those times? So let me write this down. So what I just 6 times. Okay, so we want this P would stand for the probability that I'm going to get 6 heads out of 10 tosses. Okay, so this little x would be the number of times for the specific outcome. So that would be I wanted to know how many times was the probability I would get the head 6 times. So the little x would be 6. My n is the number of trials. I tossed it 10 times. The probability of success, well, the probability of success, that would be the probability of getting a head, would be 1/2. The probability of not getting a head, that would be this probability of failure, would also be 1/2 for tossing a coin. And this factorial is the product of all integers less than or equal to, this is what you would need if you're going to use this formula up here, but we're going to use the one here that has the combination button, which hopefully you've used in Algebra 2. If you haven't, I'm going to show you where that is. So let's do this next example, and I'm probably going to back out of my computer, or out of this PowerPoint for a second. So it says, what is the probability of tossing a coin 3 times and having it land heads twice? Okay, I am not going to use the formula that they gave. We're going to go back and use this formula. So I'm going to get my piece of paper here, and I got to change my viewing here. I'm going to write this down real quick so that we have, and I'll show you, and it's really easy once you know what you're doing here. Okay, let me get out of my, let's see if I can, hopefully you can see that. Well, let's see if we can get that into the screen. Okay, there we go. So there's my formula, and I want to go back to that PowerPoint for just a second because we want to know, let's go back to this one. We want, what is the probability of tossing a coin 3 times? Toss a coin 3 times and landing heads 2 times. Okay, so let me go back to my camera here. Okay, so we're going to use this formula. So we want, and I'm going to write it down here, the probability of getting a heads, go 2H, 2 heads. Okay, this is our combination. I'm taking, I want 2 heads out of 3 tosses. So that's what this is. This is 2 heads out of 3 tosses. And then this P is the probability that I'm going to get a head. Well, that's going to be 0.5. And I raise it to the same, to this little x here, which I'm going to raise it to a 2, because that's how many times I want to see a heads. And then the probability of not getting a head is going to be 0.5. And I have 1 toss that would not be a head. And then I'm going to plug that in my calculator. Now, you all have buttons on your calculator that I'm going to try and, I don't know if I can get my screen is not super big here. So let's see if we can put this in my calculator. I have a button in my calculator. Turn mine on. If I hit my math button, and you guys probably have a PRB button, if depending on which calculator you have, but you have a button that you can go and put this little NCR in. Okay, and so then I would going to put a 3, oops, there, and I move over and I put my 2 there. And then I'm going to do times, oops, I'm going to do 0.5 raised to the second times 0.5, and then just raised to the 1, and then I hit enter in my calculator, and that's going to give me my 0.375. So this is equal to 0.375. And I know not everybody has this calculator, so if you have a different calculator, I will be glad to go over that with you and figure out how to put that in your calculator. If you have some of the calculators, you actually have to put this little number in first, this little 3 here, or the number that goes on the other side of the combination, or the C. Put that in your calculator first, then hit the PRB button for the NCR button, and then put this 2 in. I know it seems a little complicated. There's really only one problem. I think maybe 1 or 2 problems on the activity that have that, so don't get too caught up. If you don't get that, I can always help you another time. So, all right, let's go back to our screen because I think that's about it for today. Let's see. Oh, one of the things is that we have this what's called the law of large numbers. That means that the more time you do an experiment, the more trials that you have, the closer your probability will come, your experimental probability will come to theoretical probability. So for example, if you toss a coin 5 times, you might get heads, tails, heads, heads, tails. Well, that's a 60% chance of getting heads. Whereas if you toss a coin 500 times, you might get closer to 50%. So the more and more you toss, the closer and closer you're going to get, your experimental probability is going to get to your theoretical probability. And that's kind of what you're going to do today in the assignment. I think that's it, because I think that's going to be that'll be the rest of that for tomorrow. So today, I'm going to click back to my viewer, and I have this little tiny screen. I don't know if I can zoom out anymore. Oops. Wrong way. Okay, today I would like you to do this activity 4.1, data exploration. Now, if you see, I think, because I gave you black and white copies, I don't think I copied this one on color. You don't have a color screen there. You can get on your Project Lead the Way site, and it will have those colors. Otherwise, so that's what I would suggest. I'll pull that up real quick and see if I can get to that. Oops, there it is. And so if you go to your Project Lead the Way site, go to Activity 4.1.1 Data Exploration. You will be able to see the little spinner wheel in color, and then you can label your colors. One of the other things, if you don't want to flip a coin, you can get a virtual or a digital coin, and you can go to random.org. You can pick your coin, tells you what, you can even have a European coin if you want. There is also a dice in here too. And I didn't look up the dice, but if I go to home here, I'm pretty sure you can, there is a dice in here. I'll have to look for that, but I did have, oh, here we go, dice roller. So there's a coin flipper and there's a dice roller, and it will tell you how many that you're going to roll. So I think we only roll 2 at a time, and you can then roll the dice, and it will give you your dice, and you can roll it again, so you don't have to drive your parents crazy by having dice flow. But so if you want to do that, that would be really easy to do, and it's all random. So you're doing the 4.1 data exploration. You can skip E on number 4 because that's for the entire class, getting all that data together. I think everything should be pretty straightforward. Anyway, we'll talk. You can shoot me an email if you have a question. Otherwise, I think that's it for today. I'm kind of flying by the seat of my pants in this class, trying to figure out how far to go each day. So we'll see where we're at tomorrow. And so give me some feedback if this took you way too long to do. I'm going to guess that I'm probably going to give you today and tomorrow to work on this part, and then we'll come back to see where we're at after that. So have a good one. We'll talk to you later.